So I'm going to go through it. Most of you did actually really well on number 1, which is great, okay? The directions will tell you what to do on the quiz as well. It says use negative b over 2a to find the vertex, find the axis, x-intercept, y-intercept, and graph. It will also ask you for domain and range tomorrow, so I'll add that on, okay? Which domain, obviously, we all know, right? I can answer that now. Because it's a parabola, domain would be what? All real numbers, or negative infinity to positive infinity. Good. All right, so my A is 4, my B is negative 16. So X, or the H coordinate, would be negative 6, why does it write 14? 16.
Wait, if it opens up, it's K and then infinity?
Correct. Over 2 times A, and I get 16 over 8, which is 2. That's the X coordinate of my vertex. Then I take and plug that back in, so 4 times 2 squared minus 16 times 2 minus 5 is 4 times 4 minus 32 minus 5, 16, negative 16 minus 5, which is negative 21. So already 2, negative 21, I know is going to be off my graph. I'm going to label it so that I don't have to write 21 little tick marks or another 11 tick marks. You can just label it. Then I want to find my y-intercept, and that's, well, actually from here, easy would be axis symmetry, which is x equals 2. Only a couple of you forgot the x equals, but be careful, don't lose points on silly stuff like that. You will get docked points. And the axis is a line, and the line has to have an x equals a number. Otherwise, just the number is not a line. Then the y-intercept is negative 5, so 0, negative 5. And already I have all that information. Let's say you're awful at x-intercepts because this number is yucky. You at least have all the other parts, and from right now I can reflect it and be done with the graph, and all I'm missing is the x-intercepts, which obviously is going to be a loss of points, but it's way better to at least graph it based on this information than to struggle through it and not be able to finish it. Yeah.
So on the quiz, can we put the domain and range, and would that give us extra points?
It's going to ask for domain and range.
Oh.
Yeah. So I can reflect this point. Since you went up here and you went left 2, I'm going to go right 2, and then I can reflect that point to get the to get the overall shape of the parabola. My range, because it points up, is from the K, which is negative 21 to positive infinity. And the last thing it asks for is the x-intercepts. And these were big numbers. They won't be this big tomorrow. But your x-intercepts you're going to get either, if it's in standard form, you can use the even root. In this case, we didn't put it in standard form, so I'm going to take my original, set it equal to 0, and use the quadratic formula. If it's factorable, I'd factor it, okay? But most likely they're going to be yucky numbers tomorrow, so be prepared to do the quadratic formula. So negative 16 would be 16 minus the square root of negative 16 squared minus 4 times negative 5 all over 2 times a. 16 minus underneath the root, it becomes 336 over 8. And then you can break this down like 4 goes in here 84 times, 4 goes in there 21 times. That 3 and 7 don't repeat. So when you simplify that, I get 16. I don't know why I just did plus. I mean, just minus. It's plus and minus. 16 plus and minus. The 4s are going to come to the outside. Square root 21 over 8. And then 8, 4, and 16 are all divisible by 4. So it's 4, 1, and 2. And I get 4 plus and minus square root 21 over 2. And I don't want to graph those. Those are yucky numbers. So what I can do is just leave them and use that reflection that we already did to graph. So my x-intercepts and y-intercepts, you want to make sure you give in coordinate point form. You can leave it as plus and minus, but you have to put it in coordinate point form, so it would be that and then 0. Again, overall, you guys did well on this, which is good, okay? Be prepared for some weird numbers and don't freak out. Yeah. All right, this one says put in standard form and then find the vertex, axis, x-intercept, y-intercept, and graph. This time standard form means complete the square. Well, I don't know why that says from. That should say form. And again, this is going to happen twice tomorrow. So you want to be prepared for one like this where there's a number in the front. You want to be prepared for that number to be negative like the one we did yesterday in the example. You want to prepare to get fractions like you do today. Like all the different kinds and most likely yucky kinds of complete the square are what you need to be prepared for tomorrow. So the first thing we're going to do is group the 2x squared minus x and bump the 5 to the outside. I want to take the 2 out, and when you do, the x squared and the x are divided by it. You can leave that as a positive 1/2 or an x over 2. It doesn't matter. I mean a negative 1/2, sorry. Or the x over 2. Doesn't matter as long as I know that when I take that out, I'm going to do the 1/2 divided by 2 and square it. So 1/2 times 1/2, which is 1/4, and 1/4 squared is 1/16. I add it inside the parentheses, and I would balance this by subtracting it from the 5. If there was nothing on the front, I would just subtract it, but because there's a 2 here, I have to multiply it by the negative 1/16. So this becomes negative 1/8. If that 2 was negative, it would change it from negative to positive. Then you'd be adding. So that's the only time you're going to add outside is if the number you took out is negative. Now I'm going to factor, so I get 2 on the front. Square root of x squared is x. Square root of 1/16 is 1/4. Take the sign from the middle, put it in parentheses, and square it. And then I got to do positive 5 minus 1/8. So that's 40 over 8 minus 1 over 8, or 39/8. Oh, this should be plus, sorry. 39/8. And then that's your standard form. So that alone is going to earn you points. Should you get that wrong and then continue to get all the other questions wrong based on a wrong, you won't lose all the credit. Like if you get something wrong in that, but you answer like the axis based off your wrong equation, if that makes sense, or your K off your wrong equation, you're not going to lose all the points. That would be disastrous. You'll lose some, but not all. Probably even less than that. Yeah. So like if your K is wrong, you use the K again for range, right? So you wouldn't see it docked as much as, I don't know how much each individual space is worth, but it's not going to be as much as if you completely got it wrong. Sorry?
What if H and K are wrong?
Then, I mean, obviously, then you're getting the axis symmetry wrong and you're getting your range wrong. Yeah. But it will be minimal points taken after that. You'll lose points in this line, but minimal points taken after that, as long as you answer it correctly based on your incorrect equation. Yeah. Okay, so vertex we grab from this equation, we change what's after the x, so it's 1/4 and then a positive 39/8. If you want to graph that, which you're going to have to, you can convert that to a mixed number, but you don't have to give me the vertex. That in mixed number format is 4 7/8, which obviously is important when we go to graph. The axis symmetry has to be x equals, and it is x equals 1/4. Your domain is all real numbers. This opens upward, so my range is 39/8 to positive infinity. My y-intercept, I'm going to go back to the original and take the c, which is 0, 5. Then I'm going to plot that stuff before I even do my x-intercept. So 1/4 and 4 7/8 is up there. 0, 5 is here. So I went 1/4 in, or 1/4 to the left. I'm going to go 1/4 to the right to get a reflective point and draw my parabola. So the graph of this tells you what about the x-intercepts? There are none. It never crosses the x-axis, which saves you a ton of work. If you didn't catch it and you go to find the x-intercepts, you can either do it from this standard form, which because there's a fraction gets ugly, I probably wouldn't do it. If it was a whole number on the k, I would probably use the even root there. But if not, you're going to use quadratic from here. So negative b plus and minus the square root of b squared minus 4ac over 2a. And what's inside here ends up being, this would be 4, 8, so that's 40, negative 39. And you can't square root a negative number, so that's backing up the fact that there's no x-intercepts. You don't have to do that work if you graph it and you catch that there's no x-intercepts. You just write none and you save yourself some time. If I had extra time, I would probably do it just to double check that I'm right on my graph. But for sure, if you're like, that's a good way to save some time is graph it with your vertex and your y-intercept. And then if it doesn't cross through the x-axis, save yourself the time of your x-intercepts. Hadley.
Is there any question? Because you know I can just get the y-intercept from that.
Yeah.
What if it's not in that?
So on the quiz, no, because it will be all of them are in quadratic form.
Okay.
On the test, you're going to get some in standard form. And for those, you'd have to plug 0 in for x. Yeah.
So
because it doesn't cross the x-axis. But if you did the math, you would got a negative square underneath the square root.
So, would you recommend?
All right, the last one is, which will be the last one on your quiz, find the equation of the quadratic function with the given information. If this is like an easy confidence booster, jump to the fourth question and answer it, and then go back to the nonsense that was before it. So my vertex is HK, and my point is XY. That has to be, be careful there. You can't swap those, otherwise it changes the whole thing. So then I get y equals ax minus h squared plus k. Y is negative 6. A is my unknown. X is 3. H is a negative 2. So minus a negative 2 becomes plus 2. Squared plus 3. Don't forget your squared. That's the most common mistake. Negative 6a times 5 squared plus 3. Negative 6 equals a times 25 plus 3. Subtract the 3. Negative 9 equals a times 25. Divide by 25. And a is negative 9/25. And then we plug back in the a, the h, and the k. Questions on that one? Again, overall pretty good. Into 3-2. So again, we're just going to work through some of the examples here. We did the legwork yesterday on like what it is. Now we got to apply it. So yesterday we talked about the end behavior, the zeros, and the multiplicity. As a refresher, end behavior is what's happening to the arrows at the ends of our graphs. So we look to get that, we look at the degree, and the degree is the highest exponent. So if it's not in order from highest to down to no exponent, we put it in that order. You want it in decreasing degree order. If that exponent, so if it's a positive x with an odd exponent, then it falls left and rises right. If it's a negative x with an odd exponent, it rises left and falls right. If it is positive x with an even exponent, just like a parabola, both go up. And if it's a negative x with an even exponent, both point down. So that's called, the test is called the leading coefficient test, but that is to determine end behavior. Then you got the zeros or the roots or the solutions or the x-intercepts, because those are all the same thing. Well, if they're real numbers, they're all the same thing. And to do that, we just set f of x equal to 0. So we set the equation equal to 0, we factor it, we solve it. If it occurs an even amount of times, so this is my multiplicity, then it bounces off the axis and turns around at that point. If it occurs an odd number of times, it crosses through. So now we're going to put it all together. We're going to put that together with our y-intercept and plugging in some points, and we're going to figure out what these weird graphs look like. They will all be smooth and continuous, so there's no like sharp curves. They will always point in both directions. There will be an arrow at the start and an arrow at the finish. There's never a solid dot like a square root, okay? And there will never be a break in the graph, so it's not like there's a whole like a piecewise function. These are all smooth and continuous. All right, so Okay, so these are what we're gonna put all together. Determine the end behavior, find the zeros and the multiplicity, find the y-intercept, and to do this, we plug 0 in for x just like every other time. And then if we don't know the overall curve yet, we just plug in some extra points. These are not going to be perfect, okay, but these are good approximations of what our graph would look like. So this says graph, f of x equals x to the third minus 2x squared minus 5x plus 6, using what you've learned in this section. So the first thing is, wait a second. Yeah, let's change that to 3, okay, so that it's factorable.
Negative 3 or 3?
Negative 3. So we're going to start with the end behavior. Yeah.
We have it, it's not factorable.
If we when we get to, we'll get to that later. You need to learn something before you, yes, but you need to learn something no before you get to that. Yeah. Not on your test actually, because that's the last section. Yeah. All right. So this says graph using what you've learned. So we're going to start with our end behavior. Well, first we start by making sure it's in order decreasing degree, which it is. Then I want to look at the end behavior. So the highest exponent is what? 3, which is odd. That is a positive x to the third, which tells me my arrows are doing what? Falling to the left and rising to the right. So falls left, rises right. Right, a positive, an odd, falls left, rises right. Then I want to find my zeros. So 0 equals x to the third minus 2x squared minus 3x plus 6, and factor by grouping. So I take out an x squared and I get x minus 2, take out a negative 3x minus 2, and I get 0 equals x minus 2 times x squared minus 3. Can I factor the x squared minus 3? No. So when I split and solve this, the left side, I get my easy root, which is 2.
Do we get square root 3?
So you're going to get x squared equals 3, and x equals plus and minus the square root of 3. So there are 3 answers here: negative square root 3, positive square root 3, and positive 2. Do any of them occur more than once? No, which means the multiplicity on all of them is just 1, which means it's going to cross through each of those points. When I go to graph these, I'm going to approximate. So root 3 is really close to root 4, right? So like make it a 1.8. It doesn't have to be perfect, because you're not, like, I'm not going to be able to distinguish the difference between a 1.7 and a 1.8 on a graph. So this is like a negative 1.8, a positive 1.8, and then positive 2. And then plot those on your x-axis. My arrows go down on the left and up on the right. Falls left, rises right. So I already know that. And then the next thing I'm going to find is my x-intercept. I'm sorry, my y-intercept. And we already have the x-intercepts. The y-intercept I plug 0, plug 0, plug 0, and my y-intercept is 0, 6. Now I know how high I have to go before I come back down and cross back through that 1.8-ish. So this is going to come up, hit the 6, turn around, come back down, cross through the 1.8. I don't know how low to go, but I'm going to approximate and come back up. Usually if it's a small separation, it's a small dip. If there's a big separation, that's when it goes bigger. But the high and the low are approximations. It might have actually gone up first and come back down through this. It doesn't matter. You're just finding the approximate height of those curves.
Just to make sure, we figure out if it goes like left to right for the end behavior to the last one, right?
Through the highest exponent. Yeah. Questions on that one? Yeah.
So when you said that if it's even, they both go up, what is
It bounce. Oh, if the exponent is even. So if it's an x to the fourth, then my end arrows would both point up. Just like a parabola, they both point up. If it's positive and negative, they both point down. There's an x to the fourth.
So is that
All right, this one says f of x equals negative x minus 3 squared times x plus 1 times x plus 1 squared. So this is actually already factored for you. You don't have to do the work of factoring. What you do have to do that's not as easy is find the highest exponent. Now, you don't have to expand and FOIL each of these to get your highest exponent. All you have to do is figure out what each parentheses exponent would be and then add them together, because that's what you would multiply them. So like if I had an x minus 3 squared, what's the highest exponent that's going to come out of that? This was going to give me an x squared. I'm not worried about the rest of it. Then I go to the next parentheses and it's x plus 1. What's the highest exponent that's going to come out of there? Just x. And then I go to the next one and there's an x plus 1 squared. What's the highest exponent that's going to come out of that? X squared. So if I was to multiply those three things out, what's the exponent going to be? Which means it's odd. The negative on the front means it's going to end up being a negative x to the fifth. Again, I'm not figuring out any of the other parts because I don't need to. That would be counterproductive. I just need to know that, what the leading coefficient would be and what the degree would be. So because it's a negative x to the fifth, what's happening to my arrows? Rises left, falls right. Now I want to find all my zeros. So it would be 0 equals negative x minus 3 squared times x plus 1 times x plus 1 squared. Does the negative do anything with my zeros? No, right? Like if I divided both sides by negative 1 or multiplied by negative 1, it's going to go away. So the negative has actually no impact on my zeros. But this is going to get equal to 0. So 0 would equal x minus 3 squared. 0 is going to equal x plus 1. And 0 is going to equal x plus 1 squared. What do the exponents mean? There would be 2 of those. So if I solve this, my x is 3 with a multiplicity of 2. If I solve this, my x is negative 1 with a multiplicity of 1, so I leave it. And if I solve this, my x is negative 1 with a multiplicity of 2. So it's going to bounce at the 3, cross through at the negative 1, and then there's another negative 1, which means in total, how many negative 1s are there? There are 3 negative 1s.
Wait, how do you get 2 3s?
Because this is squared, so there would be 2 of them. This is squared, right? So this would be 0 equals x minus 3 times x minus 3. And you would split and solve that. There would be 2 of them. All right, so my zeros, and there's only 2 of them that are going to go on this axis, are negative 1 and positive 3. It's rising left and falling right. It bounces at the 3, so it's going to bounce and come back. It bounces at the, I went to the wrong one. It bounces at the 3, so it's going to bounce off of the one on the right. And then it has to cross through the negative 1. I don't know how low to go yet. That's what my y-intercept's going to help with. So now my y-intercept, I have to plug 0 in for x. This time I can't use just the constant because it's not set up that way. 0 minus 3 squared, 0 plus 1, 0 plus 1 squared. So I get negative 3 squared times 1 squared, negative 9 times 1, negative 9. So my y-intercept is 0, negative 9. So it bounces at the 3, it hits the negative 9, it's going to come back up and cross through that negative 1.
Why does it bounce off?
Because it has an even multiplicity. Yeah. And again, that curve, like if you graph this on a graphing utility, which we will eventually do, if it came down, it might come down lower than that negative 9 and come back up through that negative 9. We're just approximating what it is.
What's the difference like a bounce and a cross through?
This is a bounce. You mean graphing wise? Or you mean, yeah, that's a bounce. So it hits it and turns around. It doesn't actually go through it. And then this is a cross through.
Okay.
So it keeps going in the same direction, whereas the bounce, it hits it and turns around and goes back the other direction.
If it's only 2 points, can't you just like draw it in without?
You have to have at least 1 point in between each pair of intercepts. So like if I have 3 intercepts, I'd have to have 1 point here, and then like let's say it comes back down and goes back up again. You'd plug in a point from this range to figure out how low it would go there. So when we do get to like more than 1 bounces, you'll plug in points from those to figure out what happens in those spots. All right, let's do one more like that so that you can see the even. So again, it's not expanded, but I would know from this first one, this would give me an x squared, and this one would also give me an x squared. And the negative on front would give me a negative x to the 4th. So what's the end behavior like? Both point down. I get 0 equals negative x plus 2 squared and x minus 3 squared. That negative does not change any 0. I could multiply by negative 1 and it would go away. I get 2 negative 2's and 2 positive 3's. And it bounces at each. So it's going to bounce, go down, some point, come back up again, and bounce again at that positive 3. So to figure out how low I need to go, I do the y-intercept. Which is all the way off my graph. Xavier.
So